Prepare for an extraordinary cosmic event on the horizon. A colossal red giant star positioned at the edge of our galaxy is emitting mysterious signals across the universe. Utilizing the James Webb Space Telescope, astronomers have made unsettling discoveries about this massive celestial body. Renowned astrophysicist Brian Cox issues a serious warning, raising the question: are we on the brink of witnessing a catastrophic supernova explosion that could permanently alter our night sky? Let's delve into the details. In the vast expanse of the cosmos, where stars come to life, thrive, and eventually meet their end in a dazzling display, one star has recently captured the attention and concern of astronomers and the public alike. That star is Betelgeuse, a red supergiant of immense proportions and age, prominently located in the Orion constellation. While its unique reddish hue and varying brightness have long fascinated observers, recent developments have intensified interest in this celestial giant. As we explore the nature of Betelgeuse, we find ourselves on the verge of a potentially monumental event in the star's life cycle. But what could these changes in Betelgeuse signify? Are we witnessing the prelude to an unimaginably grand cosmic spectacle? Betelgeuse, approximately 764 times larger than our Sun, stands as a stellar behemoth of colossal size almost beyond human comprehension. Imagine a star so immense that if it were to replace our Sun, its surface would extend beyond the orbit of Mars, enveloping Mercury, Venus, Earth, and Mars in its stellar embrace. This remarkable size not only showcases Betelgeuse's physical attributes but also highlights its stage in the stellar life cycle as a red supergiant. Betelgeuse is in the twilight of its existence, marked by expansion and cooling after a lifespan fusing hydrogen into helium in its core. Despite being relatively young in human terms at around 8 to 8.5 million years old, Betelgeuse's current red supergiant phase is the result of millions of years of stellar evolution, transforming from a hot blue star to the red giant we see today. Betelgeuse's distinctive reddish hue stems from its cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,000 to 3,500 Kelvin, emitting light at wavelengths that give it a red appearance. This color is not just visual but offers insights into the star's physical condition and the processes within its vast gaseous expanse. Adding to Betelgeuse's mystique is its historical color change. Ancient Roman and Chinese writings suggest it was a yellow star about 2,000 years ago, with Arabic scholars first describing it as red in the 9th century. This color shift over human history provides valuable clues about the star's evolutionary path. The variable brightness of Betelgeuse is equally intriguing. As a semi-regular variable star, its light periodically waxes and wanes in a characteristic dance of luminosity, following a 400-day cycle and a longer cycle spanning about 5 years. These cycles have been documented since 1836 by Sir John Herschel and possibly even earlier in Aboriginal oral traditions. But what adds to the mystery of Betelgeuse is not just its changing brightness but its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse sometimes deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes within its colossal form. In a recent groundbreaking revelation, Betelgeuse grabbed the attention of astronomers and stargazers worldwide with an unexpected and dramatic change in its appearance, famously known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, began to mysteriously dim. The star's dimming was so pronounced that it started losing its luminosity at an average rate of 0.1 magnitudes per day, reaching its lowest brightness in February 2020. Betelgeuse, normally visible to the naked eye even in light-polluted areas, became noticeably fainter, a change even amateur observers could detect. However, there's a challenge when trying to monitor Betelgeuse's activities: the time paradox. When we observe a star like Betelgeuse, we're not seeing it as it exists in the present but as it was in the past, due to the time it takes for light to travel to us. In Betelgeuse's case, approximately 725 light-years away, the light we perceive today left the star nearly 7 centuries ago. This time lag makes it difficult to predict and monitor sudden changes in a star's behavior, as we are essentially peering into its past. Andrea Dupree, associate director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored the unfolding celestial drama using the Hubble Space Telescope. They analyzed the behemoth star as part of a 3-year study to monitor variations in Betelgeuse's outer atmosphere. These observations provided unique insight into the dynamics of a variable star like Betelgeuse, which regularly expands and contracts, causing fluctuations in brightness. Hubble's sensitivity to ultraviolet light allowed researchers to probe the layers above the star's surface, heated partly by the star's turbulent convection cells. Further analysis of the Hubble spectra taken at different points throughout 2019 and 2020 helped measure the movement of material in Betelgeuse's outer atmosphere, specifically focusing on magnesium-Roman II lines indicative of the star's atmospheric conditions. These observations revealed material moving at speeds of about 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's dimming. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss was significant, especially considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate far greater than that of our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. The proximity of Betelgeuse, about 725 light-years from Earth, adds to the intrigue, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. Yet, the question remains, what does this dimming event portend for Betelgeuse's future? Is it an indicator of an impending supernova or simply a unique episode in the star's long life? Several theories were proposed to explain this sudden change. One prevalent theory suggested a phase in the supernova explosion process, gaining traction due to the common belief that Betelgeuse is nearing the end of its life. Another widely discussed theory pointed to the possibility of dust, potentially originating from Betelgeuse itself, obstructing our view. Red supergiants like Betelgeuse are known to shed material, and it was suggested that this material could form a dense dust cloud, causing a dimming effect when observed from Earth. Another explanation considered changes in the star's photosphere, the visible surface layer, which might influence its apparent brightness. To unravel this mystery, an analysis using various observational methods was employed. Spectroscopic studies revealed the decline in Betelgeuse's effective temperature, indicating that the dimming might be attributed to a large dark spot on the star's surface. Supporting this theory was the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, suggesting significant surface changes. Ultimately, the breakthrough in understanding this peculiar event came from the Hubble Space Telescope, humanity's watchful eye in outer space. Hubble's observations indicated that Betelgeuse's dimming was likely caused by a substantial ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, diminishing the amount of light reaching us from Betelgeuse. The dust cloud was believed to have originated from superhot plasma ejected from a large convection cell on the star's surface. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, beginning in January 2019, played a crucial role in piecing together the timeline leading up to Betelgeuse's darkening. These observations captured signs of dense, heated material moving through the star's atmosphere in the months preceding the dimming. In December 2019, several ground-based telescopes observed the star decreasing in brightness, particularly in its southern hemisphere. The material, initially more luminous than the star's normal brightness, eventually led to the formation of a dark cloud as it moved outward and cooled. The hypothesis suggested that this outflowing material and the resulting dark cloud caused the sudden dimming of the star. The magnitude of this adjustment was truly monumental, propelling Betelgeuse into the astronomical spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material, believed to be several times as much as our Moon, was a significant event not only for Betelgeuse but for advancing our understanding of stellar mechanics. What implications does such a massive ejection of material hold for Betelgeuse and supernova theories at large? The implications are profound, challenging traditional understandings that red supergiants shed mass at a steady pace before their explosive demise. Instead, the scale of this ejection suggests a more turbulent and possibly unpredictable end-of-life phase for these stars. Could Betelgeuse be gearing up for its grand finale, a supernova explosion within the next few millennia? Recent studies speculate about the timing of such an event, suggesting it could occur sooner than previously thought, potentially in just a few tens of years. Another crucial aspect in the Betelgeuse puzzle is the concept of bow shock. As this colossal star moves through space at approximately 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock resembling the wave formed by the bow of a moving ship. This phenomenon occurs as the star's outer layers interact with interstellar gases and dust, providing a spectacular testament to the star's dynamic nature and its interaction with the cosmic environment. Studying this bow shock not only informs us about Betelgeuse's current state, but also contributes to our understanding of stellar evolution and mass loss processes. But what about Betelgeuse's recent behavior? Observations reveal that Betelgeuse's surface has cooled and become less dense following the massive ejection event, leaving the star in an unstable state even years later. Hydrodynamic simulations suggest a link between the star's convective activities, the mass ejection, and subsequent pulsation mode switching. This ongoing instability raises questions about the internal processes driving these changes and how they might unfold in the future. Furthermore, Betelgeuse's observed mass loss rate is notably higher than many other stars, indicating a complex set of circumstances surrounding its evolution and behavior. The saga of Betelgeuse is far from over as astronomers continue to monitor and study this enigmatic star, seeking answers to the profound questions it raises about stellar life cycles, supernova explosions, and the nature of the universe itself. In conclusion, Betelgeuse stands as a cosmic marvel, a giant among stars whose every flicker and change captivates our imagination and pushes the boundaries of our understanding. Whether it heralds the dawn of a spectacular cosmic event or simply marks another chapter in the ongoing saga of stellar evolution, Betelgeuse remains a beacon in the night sky, reminding us of the vastness and complexity of the cosmos. Recent advancements in our understanding of Betelgeuse have illuminated its complex dynamics and hinted at future astronomical marvels. The star's variability, particularly its semi-regular dimming and brightening cycles, continues to intrigue astronomers worldwide. These cycles, observed since the 19th century, are pivotal in deciphering the underlying mechanisms governing Betelgeuse's behavior. Moreover, Betelgeuse's recent great dimming event in late 2019 captured global attention and sparked intensive scrutiny. This unprecedented dimming, where the star's luminosity dropped significantly, posed fundamental questions about stellar evolution and potential catastrophic events like supernovae. Astronomers mobilized ground-based telescopes alongside space-based observatories like the Hubble Space Telescope to scrutinize the star's every fluctuation and atmospheric disturbance. The aftermath of the Great Dimming revealed fascinating insights into Betelgeuse's outer atmosphere. Observations indicated a rapid ejection of superheated material from the star's surface, forming a dense dust cloud that partially obscured its brilliance. This phenomenon provided a rare glimpse into the dynamics of mass loss in red supergiants, shedding light on processes that influence the fate of massive stars. As astronomers continue to monitor Betelgeuse, the star's spectral analysis has unveiled intriguing shifts in its chemical composition and atmospheric dynamics. Variations in spectral lines, such as magnesium Roman II lines, offer clues about the star's internal processes and ongoing evolution. These spectral studies, combined with theoretical models and simulations, contribute to a more comprehensive understanding of Betelgeuse's complex behavior. Furthermore, Betelgeuse's proximity to Earth, at approximately 725 light-years, presents a unique opportunity for detailed observation. Astronomers leverage this proximity to study the star's pulsations, convective movements, and interaction with its surrounding interstellar environment. Each observation deepens our knowledge of red supergiants and their pivotal role in shaping the cosmos. One of the lingering mysteries surrounding Betelgeuse is its variability in brightness. While most red supergiants exhibit periodic brightness fluctuations, Betelgeuse's irregular dimming events defy conventional explanations. The star's recent dimming event, although spectacular, raised concerns about the potential for a supernova explosion in the near future. However, astronomers emphasize the need for continued observation and data collection to discern whether these dimming events are precursors to such cataclysmic events. Moreover, studies of Betelgeuse's bow shock phenomenon have yielded valuable insights into its interaction with interstellar medium. The star's swift movement through space generates a shock wave that shapes its surrounding environment, providing astronomers with a unique laboratory to study astrophysical processes at play. These studies not only enrich our understanding of Betelgeuse but also contribute to broader research into stellar astrophysics. In recent years, advancements in observational technology have revolutionized our ability to study stars like Betelgeuse. From ground-based telescopes equipped with adaptive optics to space-based observatories capable of capturing high-resolution images, these tools have enabled unprecedented insights into the lives of stars. Collaborative efforts among international research teams have further expanded our knowledge base, fostering a global exchange of ideas and discoveries. Looking ahead, astronomers are poised to confront new challenges in unraveling Betelgeuse's mysteries. Future missions, such as the James Webb Space Telescope, promise to unveil deeper layers of the star's atmospheric composition and dynamic behavior. These endeavors will shed light on the fundamental processes governing massive stars and their ultimate fate. In conclusion, Betelgeuse stands as a celestial enigma that continues to captivate and inspire astronomers worldwide. Its profound influence on our understanding of stellar evolution, supernovae, and cosmic dynamics underscores its significance in astrophysical research. As we embark on future explorations of Betelgeuse and beyond, we remain poised to uncover new revelations that expand the frontiers of human knowledge and deepen our appreciation for the vastness of the universe.